Welcome, my dear students. I would like to speak with you about some important problems in algebra. Number 1. Write the matrix aig of order 3 times 2, where aig equal 2I minus g. This is the solution. E11 equal 2 times 1 minus 1 equal 1. E1 2 equal 2 times 1 minus 2 equal 0. E21 equal 2 times 2 minus 1 equal 3. E22 equal 2 times 2 minus 2 equal 2. A31 equal 2 times 3 minus 1 equal 5. E32 equal 2 times 3 minus 2 equal 4. Therefore, AIG equal this matrix of elements 1, 0, 3, 2, 5, and 4. Number 2. If this matrix of elements 10, negative 20, negative 8, and 16 equal negative 2 times this matrix of elements negative 5, 5x, 4, and negative 2y. Then find the value of the cubic root of xy. Solution: since this matrix of elements 10, negative 20, negative 8, and 16 equal this matrix of element 10, negative 10x, negative 8, and 4y. Therefore, negative 20 equal negative 10x. Therefore, x equal 2. 16 equal 4y. Therefore, y equal 4. Therefore, the cubic root of xy equal the cubic root of 8. This equal 2. Number 3. If A equal this matrix of elements 5 to x, 8, negative 4, negative 3, 6, x plus 2y, 6, and 4 is a symmetric matrix, then find the values of x and y. Solution: since A is a symmetric matrix, therefore 2x equal negative 4. Therefore, x equal negative 2. X plus 2y equal 8. Therefore, negative 2 plus 2y equal 8. Therefore, y equal 5. Number 4. If A equal this matrix of elements 1, negative 2, 3, 5, 4, and 2, B equal this matrix of elements negative 1, negative 2, 5, 1, 3, and 2, and C equal this matrix of elements 2, 0, negative 1, 3, 4, and 6. Find 2A plus CT. Solution 2A plus CT equal 2 times this matrix of elements 1, negative 2, 3, 5, 4, and 2 plus this matrix of elements 2, 0, negative 1, 3, 4, and 6. All of this transpose. All of this equal this matrix of elements 2, negative 4, 6, and 10, and 8 and 4. All of this plus this matrix of elements 2, 3, 0, 4, negative 1, and 6. This equal this matrix of elements 4, negative 1, 6, 14, 7, and 10 by adding the corresponding elements. Now, number 5, find A, B, if A equal this matrix of elements 2, 1, 3, negative 1, 0, and 4. B equal this matrix of elements negative 1, 2, 0, and negative 3. Solution AB equal this matrix of elements 2, 1, 3, negative 1, 0, and 4 times this matrix of elements negative 1, 2, 0, and negative 3. Notice that the number of columns in the first matrix, 2 columns, equal the number of rows in the second matrix, 2 rows. We multiply the first row times the first column. Then we multiply the first row times the second column. Multiply the first row times the first column, 2 times the negative 1 plus 1 times 0. Multiply 2 times the negative 1 plus 1 times 0. As you see here, multiply 2 times 2 plus 1 times negative 3. The first row times the second column. Look at this element. The second row times the first column. Then the second row times the second column. Then the third row times the first column, and the third row times the second column. We obtain this matrix of elements negative 2, 1, negative 3, 9, 0, and negative 12. Notice there is a distribution here. Now, Number 6. If A equal this matrix of elements -1, 2, 0, 3, then prove that E power 2 minus 2E minus 3I equals 0. Solution: A power 2 minus 2E minus 3I equal this matrix of elements -1, 2, 0, and 3. All of this times this matrix of elements -1, 2, 0, and 3. All of this minus 2 times this matrix of elements -1, 2, 0, and 3, minus 3 times this matrix of elements 1, 0, 0, and 1. Unit matrix. All of this equal the matrix of elements 1, 4, 0, and 9 minus this matrix of elements -2, 4, 0, and 6 minus this matrix of elements 3, 0, 0, and 3 equal this matrix of elements 0, 0, 0, and 0, 0 matrix. Now, number 7, find the value of this determinant. We have elements 2, 5, 3, and 8 inside the determinant. Solution: multiply the elements of the main diagonal 2 times 8 minus 3 times 5 other diagonal. Again, multiply the elements in the main diagonal minus the product of the other diagonal. Multiply 2 times 8 minus 3 times 5. You will obtain 1. This is the value of the determinant. Now, number 8. Find the value of x if this determinant of elements x squared minus 4, 1, 0, and 1, all of this determinant equals 0. What is the value of x? Solution: multiply x squared minus 4 times 1 minus 0 times 1. 0 times 1. Again, multiply the elements of the main diagonal minus the product of the elements in the other diagonal. As you see here, x squared minus 4 times 1 minus 0 times 1. This equals x squared minus 4. Therefore, x squared minus 4 equals 0. Therefore, x squared equals 4. Therefore, x equals positive or negative. The root of 4 equals positive or negative 2. Number 9. Find the value of this determinant. Inside this determinant, we see the elements 2, 3, -1, -2, 0, 4, 1, 1, and -3. Solution: using the elements of the first row, we have this determinant equal 2, look at 2 times this determinant 0, 4, 1, negative 3, why? Cancel this column and this row, you will obtain this determinant of elements 0, 4, 1, and negative 3 here. Take 3 here with negative according to the rule of signs. The second element in the first row, we put beside it negative as you see here. Cancel this column and this row. What is the remainder? Negative 2, 4, 1, and negative 3. Put it here. Plus negative 1. This element, put it here. Beside it, put this determinant after cancelling the row and the columns, which consists of negative 1. What is the remainder? Negative 2, 0, 1, and 1. The elements here, collect them in this determinant according to the rules of expanding and the rule of signs. Review the rules. And now, expand every determinant. By the previous rule, we have this equal 2 times 0 times negative 3 minus 1 times 4. All of this minus 3 times negative 2 times negative 3 minus 4. All of this negative or minus negative 2 times 1 minus 1 times 0 equal 2 times 0 minus 4 minus 3 times 6 minus 4 minus negative 2 minus 0 equal 2 times negative 4 minus 3 times 2 plus 2 equal negative 12. Number 10. Find the area of the triangle whose vertices are x ordered pair 1 and 2, y ordered pair 3 and negative 4, z ordered pair negative 2 and 3 by using determinants. Solution: A equal half of this determinant. Notice that the first column consists of elements which are the first projections here 1, 3, negative 2. Notice that the second column here consists of the second projections 2, negative 4, and 3. Put them here in the second column. The third column consists of 1, 1, and 1 also. By using the elements of the third column, therefore A equal half times this determinant of elements 3, negative 4, negative 2, and 3 minus this determinant of elements 1, 2, negative 2, and 3 plus this determinant of elements 1, 2, 3, and negative 4. All of this equal half times 9 minus 8 minus 3 plus 4 plus negative 4 minus 6. This equal half times 1 minus 7 minus 10 equal negative 8. It implies the area equal the modulus of negative 8, or the absolute value of negative 8 equal 8 square units. Number 11, solve the system of the following equations using Cramer's rule. 6x minus 5y equal negative 23. 3x plus 3y equals 16. Solution: delta equals this determinant of coefficients 6 and 3 in the first column, negative 5 and 3 are in the second column. The coefficient expand this determinant by using the rules. We have this equals 6 times 3 minus 3 times negative 5. All of this equal 33. Now delta x equals this determinant, negative 23, negative 5, 16, and 3. Why? Notice that negative 23 and 16 are the constants in the first column. Notice that the second column consists of the coefficient of y. Expand this by using the rules. We obtain the value of this determinant equal negative 23 times 3 minus 16 times negative 5. This equal 11. Look at delta y equal this determinant. Inside it, we have elements 6, negative 23, 3, and 16. Why? Notice that 6 and 3 are the coefficient of x. Notice that negative 23 and 16 are the constants, which are free of x and y. All of this determinant equal what? By using the rules of expanding 6 times 16 minus 3 times negative 23. Again, 6 times 16 minus 3 times negative 23. As you see here, all of this equal 165. Therefore, x equal delta x over delta. By substitution, we have 11 over 33 equal 1 over 3. And y equal delta y over delta equal 165 over 33 equal 5. And the solution set equal this set of ordered pair, which consists of the elements 3 and 5 inside the ordered pair, which is inside also this set. Set consists of ordered pair, which consists of 3 and 5. Now, number 12. Find the multiplicative inverse of the matrix A equals this matrix of elements negative 2, 2, 3, and negative 4. Delta equal determinant of A equal determinant of elements negative 2, 2, 3, and negative 4. The given elements expand by using the rules. This equal negative 2 times negative 4 minus 3 times 2. The mean diagonals minus the other diagonal. The product of the elements in the mean diagonals minus the product of the elements in the other diagonal. All of this equal 2. This doesn't equal 0 since the determinant doesn't equal 0. Therefore, the matrix E has a multiplicative inverse. A minus 1 equal 1 over delta times this matrix of elements D, negative B, negative C, and A, where E equal this matrix of elements A, B, C, D. This rule, we apply this rule to obtain the matrix A minus 1 multiplicative inverse equal 1 over 2. Notice that 2, put it here in the denominator. The value of the determinant, put it in the denominator according to the rule. Put 2 here. Now half times this matrix negative 4, negative 2, negative 3, and negative 2. Why? According to this rule. Alternate these elements of the mean diagonals and change the sign of the other diagonal. Alternate this, put it here and put it here. Put negative 2 instead of negative 4 and negative 4 instead of negative 2, as you see here. Change the sign of negative 2 and negative 3, as you see here. By distribution, we obtain this matrix, which consists of elements negative 2, negative 1, negative 3 over 2, and negative 1. Now, number 13. Solve the following system of linear equations by using matrices. 2x plus 3y equals 7, x minus y equal 1. Solution. The matrix equation is Ax equals C. E here is a matrix. X here is a matrix of the unknowns. E is a matrix of coefficient. X is matrix of unknowns equal the matrix of the constants, where A equal the matrix of elements 2, 3, 1, and negative 1. X equal the matrix of elements x, y, which are unknown. C equal the matrix of elements 7 and 1, which are constants. 7 and 1, put them here. Since delta equal the absolute value, delta equal this determinant of E, delta equal the determinant of A. Determinant of A is the determinant of elements 2, 3, 1, and negative 1. The coefficients, the determinant of coefficients of x and y the coefficient of x in the first row, the coefficient of y in the second column. Again, the coefficient of x in the first column and the coefficient of y in the second column. All of this equal -5. E minus 1 equal 1 over -5 times this matrix, -1, -3, -1, and 2 equal this matrix of element 1 over 5, 3 over 5, 1 over 5, and -2 over 5. Since x equal e minus 1c, this is a rule. X equal 1 over 5, 3 over 5, 1 over 5, and -2 over 5. All of this times this matrix of elements 7 and 1. All of this equal this matrix of elements 2 and 1. The matrix of elements x and y equal the matrix of elements 2 and 1. Therefore, x equal 2 and y equal 1. And the solution set equal this set, which consists of the ordered pair 2 and 1. Thank you very much. Best wishes from me for all of you. Goodbye.